Hello everyone! Today we're going to take a look at how to create an artificial intelligence system on EzSpark using the GYM environment. So, first of all, what is GYM? GYM is an open source Python library for developing and comparing reinforcement learning algorithms by providing us a standard API to communicate between learning algorithms and environments, as well as a standard set of environments compliant with that API. So, in summary, GYM is just a library written in Python, usually used to create API endpoints for your custom game to interact with. Hence, a GYM environment can be seen as a game developed in Python, which exposes some APIs, such as the rewards for some of the actions of the game, the current state of the game, the set of actions that can be taken, and so on. The goal of these set of videos is to create a game developed in Python, how to wrap it in a GYM environment, exposing some standard functions, and create an artificial intelligent model able to play the game with GYM using this distributed training of EzSpark. So, first of all, what you're going to see is the structure you must follow to create the GYM environment. So the structure you must follow is written in this file, the structure.txt file. As you can see from here, we have a game folder that is the parent folder of everything related to the environment. We can match this folder with the current example that I have created. The game folder in this case is the GYM My Tetris folder. Inside this folder, we have another file, named as the setup.py file. Why do we need this file? Because you need to install the environment locally using pip. In the setup.py file, we are going to write everything you need to install it locally. After that, we have our game subfolder. Let's take a look inside this folder. So, the setup.py file will be written after a while. I named it the same as the parent folder, but with the underscore. Indeed, I named this folder GYM_MyTetris. So, as you can see here, in this folder, I named it GYM_MyTetris, and you can name it whatever you want. Inside of this subfolder, we have a file named init.py file. This file is needed because you're gonna register the name of your game with pip. So, inside GYM_MyTetris, we have the init.py. The file would be something like this. You import register from git.envs.registration, and then you're gonna register the name of your game, and then you'll also set the entry point. The entry point in this case is given by the folder you are in. So here we are in gym_mytetris.envs:\mytetrisenv. MyTetrisEnv is the class that will be exposed by the files inside envs. Okay, taking a look at the structure.txt, the envs directory, that is this one, inside of it we have our init.py file and a game.py file. Obviously, the game.py file can be named as you want. In this case, I named it mytetris_env. So, in the init.py file, we're going to expose the class that is written inside this file. You can see from here what the init.py file includes. From gym_mytetris, which is this directory.envs, mytetris.envs, this file, then import mytetrisenv, which is this class written inside this file. As you can see here, I got the class mytetrisenv, and we are going to implement it following the standards of GYM. This again is all included in the mytetris_env.py file. Going back to the parent folder, here you can see what you need from the requirements. In this case, we just need GYM. Then, if you need some matrix manipulation, I would recommend you to also install NumPy. Okay, after that, to make this GYM environment compliant with the training with EzSpark, we need to follow some constraints. So, first of all, EzSpark needs a GYM environment where you have a discrete state space, a discrete action space, and then you must also implement some functions. Okay, what does it mean having a discrete state space? It means that you just have a list, or a list of lists, or a NumPy array where you have numbers. And this means that your space is going to be discrete. So, in conclusion, what I really want to say, you can manipulate this list or list of lists with NumPy arrays or simply with the standard lists of Python, just like here. After that, we also need to have a discrete action space. What does that mean? This means that in your game, you can just take a number of actions that go from 0 to n. And so, the actions you can take are actions 0, 1, and 2, and so on, until the n minus 1. Also, the final constraint is to create some standard functions that are standard for Gym. They are step, reset, and close. That's it. In the next video, I will implement the game of Tetris following this structure and all these constraints. Thank you for watching. See you in the next video.